Hi, I'm Ms. Cho, and in this video we'll divide rational expressions. Rational expressions are one polynomial divided by another one, and we can divide them by each other just like we divide fractions. So for example, if I had 3/4 divided by 1/2, I would change this into a multiplication problem by using the reciprocal of the divisor. In other words, I'm going to flip. I keep my original fraction, I change my division to multiplication, and I flip or use the reciprocal of my divisor. From there, it's just like multiplication where I multiply across the top. So I have 3 times 2 divided by 4 times 1. I can rewrite my 4 as 2 times 2. And I notice that I have a 2 in the numerator and a 2 in the denominator, so I can cancel them out. And I have 3/2 left as my simplest form fraction. When we divide rational expressions, we're going to do the same thing. We keep, we change, we flip. So this becomes a multiplication problem where we are taking d over x divided by c over cx. Let's take a look at an example. Here we're asked to find the quotient and domain of x over x squared divided by x squared plus 6x minus 27 divided by x squared minus 9. First, we're going to change this into a multiplication problem using the reciprocal of the divisor. Then we continue on just like multiplication. We factor our expressions, we find the zeros of our denominators, and then we multiply across and cancel any common factors that appear in both our numerator and denominator. So when I rewrite this as a multiplication problem, I have x divided by x squared times x squared minus 9 over x squared plus 6x minus 27. Here, I'm going to factor my numerator and denominator. So I have x divided by x times a difference of squares, which is x plus 3, x minus 3. And then I'm looking for two numbers that multiply to negative 27 and add to 6. So I think that's going to be positive 9 and negative 3. And then now I'm going to find the zeros of all my denominators. So if I have x squared equals 0, that gives me x equals 0. X plus 9 equals 0 gives me x is equal to negative 9, and x minus 3 equals 0 gives me x equals 3. So these are all the excluded values from my domain. From here, I can multiply across and cancel any common factors. I see that I have an x in both my numerator and denominator, so I cancel one of each. In my second expression, I see that I have an x minus 3 in both the numerator and denominator. So I am left with an x plus 3, an x, and an x plus 9. And my domain are all x's except for the ones that we found in step 3, which were x equals 0, negative 9, and positive 3. Even though 3 doesn't look like it'll cause any problems for this denominator, it makes our original denominator 0, and so we must exclude it from our domain. Let's try a second example. In this example, we're asked to find the quotient and domain of x squared minus 36 over 8x plus 48 divided by x squared minus 4x minus 12 over 2x. We're going to change this into a multiplication problem by using the reciprocal of the second expression. So this is going to be multiplied by 2x divided by x squared minus 4x minus 12. From here, I'm going to factor. I have a difference of squares in my numerator, so I have an x plus 6 times an x minus 6. In my denominator, I have GCF of 8, which leaves me with an x plus 6. And then on my denominator, I'm looking for two numbers that multiply to negative 12 and add to negative 4. So I think that's going to be negative 6 and positive 2. So once I have factored all my expressions, I can look and see what makes my denominator 0. So x plus 6 equals 0 gives me x is equal to negative 6. X minus 6 equals 0 gives me x is equal to positive 6. And x plus 2 equals 0 gives me x is equal to negative 2. Now that I have all my excluded values, I can cancel any common factors that appear in both a numerator and a denominator. So I see that I have an x plus 6 in a numerator and an x plus 6 in the denominator. I have an x minus 6 and an x minus 6. So that, and then I have 2 and an 8. So 2 goes into 2 once, 2 goes into 8 4 times. So I am left with an x and then a 4 times an x plus 2. as my final simplified expression. My domain is going to be all x's except for the ones that we found here. So this is going to be except for x equals 6, -2, and -6. Let's summarize. When we divide rational expressions, we change them into multiplication problems using the reciprocal of the divisor, or keep, change, flip. From there, we just treat it like multiplying fractions. We're going to factor our numerator and denominator of each expression. We find the zeros of our denominators, and then we multiply across the numerator and denominator to cancel any common factors that appear in both. Our domain includes all undefined values in the multiplication step. And this has to be with the original denominators, not the simplified.